Hi guys, welcome back to the channel. Today I'll show you how to build a scalable and decoupled backend for an application using Kafka and Python. I'll use the example of a food ordering app, but it does not really matter what your app is. It's more about the system we build and how it can scale very easily. I will build the whole system locally using a locally running Kafka broker. But of course, in a production setting, you will want to run multiple Kafka instances in a more mature environment. So, without waiting any longer, let's get started. The first thing I have over here is a system diagram of how the whole system is going to look like. Over here, we have the front end of the whole application. We're not going to code the front end, but we can assume this is going to be either a mobile app or a web app. When a user orders food using the app, the front end is going to call our backend endpoint called orders backend. Once again, we're not going to write the endpoint, we're just going to simulate an endpoint, because the point of the video is to show you how the whole thing works rather than individual details of each of the component. So orders backend, it's going to take in an order from the front end, format a payload with all the data related to that order, and then write to Kafka to a topic called order details. The topic order details is going to encapsulate all the information related to one individual order. And then we have our transactions backend over here, which is going to be a separate Python file. In a production setting, it can be a microservice or some kind of AWS Lambda function. But in our case, just for simulation purposes, we're just going to have it as a Python file. So the transactions backend is going to be subscribed to the order details Kafka topic, so that whenever someone writes to the order details Kafka topic, the transactions backend is going to read the message and process it in real time. We're going to assume that the transactions backend is going to do some credit card processing and some other checks to make sure that the order is confirmed. Once the order is confirmed, it's going to write back to Kafka to a different topic called order confirmed. The point of the order confirmed topic is to encapsulate all data related to an order that has been confirmed and it's being worked on right now. And then we have other backend services like an email backend and an analytics backend. Just for instance, email backend can be a different backend service that you have, which is going to send out a confirmation email to the user when the order is confirmed. So once again, this is going to be subscribed to the order confirmed data pipeline topic and going to send out an email whenever a message is written to that topic. Similarly, we have our analytics backend, which is going to perform some analytics. Let's say it's going to aggregate the total number of orders in that day and the total number of revenue coming from different orders. So it is going to be subscribed to order confirmed, and whenever an order is confirmed, so whenever a message is written to that topic, it's going to do some calculation, and we're going to see how it can retain the state and do other computations based on the state. So that's how the architecture looks like. Now let's dive down into the code. All right, so over here is going to be the Python code. I'm going to do everything from scratch, but just to show you the structure, we have a Docker Compose file. This is pretty much some boilerplate. You can just copy paste. I'm going to have the code in GitHub, so you can just look at it over there. So what we're essentially doing is we're spinning up a Zookeeper instance and a Kafka instance and running both of them locally. So if we look at our Docker, let's see if they're running, otherwise we're going to kick it off. Yep, so we already have the whole instance running. You can see we have one Zookeeper instance and one Kafka instance. So yeah, pretty straightforward. The code is going to be there, so you can just copy that. And then we're going to have the individual files for each of the component that I mentioned over here. So we'll have an orders backend, email backend, analytics, and transactions. Right? Yep, I'm going to do all of them from scratch so that it makes more sense. So the first thing we are going to do is, if you look over here, given we're abstracting away the client, we're going to assume that the client has hit our orders backend microservice or instance. So let's go to our order backend, and then we're going to delete all the code so that we can start from scratch. And let's start from there. So the first thing we're going to do is import everything that we need. So we need to import JSON, and we need to import time. And then we have our, I'm gonna zoom in, there you go. And then we have our Kafka package. From there, we're gonna import Kafka producer. For information, what we're using is a package called kafka-python. So you could just install it with pip. So we have the producer, and now we need our topic, which is gonna be the Kafka topic. We're gonna call it order details. Let's say we're gonna have 15 orders, just to keep things simple. This is gonna be the simulated orders. We instantiate the producer. This is good. So the producer is everything that's gonna write to Kafka, and consumer is anything that's gonna read from Kafka. So we have a Kafka producer, and you have to give it the server. I think it's called the bootstrap servers. This is going to be the server where your client is running. So if you look at the Docker compose file, our Kafka is running on port 29092. So we're going to just do localhost port 29092. That's our producer. Let's just print going to be generating order after 10 seconds. There we go. And then we're gonna generate one unique order every 10 seconds. All right, so that's what we're gonna be doing. So let's just put some print statements to make it clear. And now we're gonna do for I in range from 1 to our order limit, which is 15 in this case. We're gonna simulate the data, which is gonna be the order ID. Let's say that's gonna be I. And then we're gonna have the user ID, which is gonna be, let's say, Tom_I. That means as we iterate through the orders, the first user ID is gonna be Tom1, Tom2, Tom3, all the way to Tom15. So we have the user ID, and then we have the total cost of that order. For example purposes, we're just gonna do I, which is the variable over the ID, and then multiply it with, let's say, 2. Once again, this is just to make sure that the orders are unique. In a real application, you'll have actual data coming from the front end. And then we have the items which we really don't need, but just for example, we can have like a burger, sandwich, or whatever. Right? So we have the order ID, the user ID, total cost, and items. These are all the data that's going to be written to Kafka. And now that we have the data, we're going to do producer.send. And to send, you have to give it the topic. In our case, it's going to be the Kafka topic, the order Kafka topic over here. So it's going to be writing to the topic called order details. And we're going to pass in the data. But to pass in the data, we need to encode it. So we're going to do json.dumps, and then we're going to dump the whole data. And after dumping the whole data, we're just going to encode it to be UTF-8. All right, so we're sending our data to this topic over here. And once we send the data, let's just print something out. Done sending, and then let's do the ID. And then we're gonna sleep for, let's say, 10 seconds. So we're gonna send a message, sleep for 10 seconds, send the other one. So this should be our order backend. So let's try to run it to make sure it works. We have our iTerm. So I divided this into 4 separate chunks to make things easier. So I'm going to start from top left. we're gonna do Python 3 order backend. So you can see we have done sending 1. We should go all the way to 15. We're gonna wait 10 seconds and then 2, and then after further 10 seconds it's gonna be 3. So going to the code, all we're doing is we're iterating from 1 to 15, and for every value of I, we're forming the data with that value. We're sending the data to the order details Kafka topic, and before sending the data, we're turning it into a JSON object and then encoding it with UTF-8 so that Kafka can read it and decode it correctly. And then we're sleeping for 10 seconds before repeating the whole thing all over again. So 5, so you can see it's gonna go up to 15. So we know that this works. I'm gonna close it out. There we go. All right, so we know that part works. So we have our order backend done. So going to the system architecture diagram, we have this done, which is writing to the topic order details into Kafka. Now let's move to the transactions backend, which is going to be a consumer reading from this and writing back to Kafka. Right, so we're going to go back to our transaction. There you go. So let's go to transaction. I'm going to delete all the code so that we can start from scratch. All right, once again, the imports, so we need JSON, and then from Kafka, we need to import Kafka consumer, and we need to import Kafka producer. So there we have the producer and the consumer, and now let's instantiate the consumer. The consumer is going to take in the topic because you have to tell Kafka which topic your consumer is consuming from. So we're going to give it the topic. Before that, let's get the constant. So we have our order Kafka topic. This is going to be our previous topic called order details. And then we're going to have, so order details is what the consumer is going to read from, and then it's going to write to another topic called order confirmed. So let's write that down. So we're going to have order confirmed Kafka topic, and we're going to call it order confirmed. There we go. To the consumer, you have to tell it which topic you're consuming from. So that's going to be our order Kafka topic. And once again, you have to give it the server, which is going to be in our case, Bootstrap servers. And giving it the server, it's going to be localhost 29092. All right, so we're going to be consuming from the same topic that we're writing to. And we need the producer, which is going to be once again Kafka producer, and you just give it Bootstrap servers, which is going to be localhost 29092. All right, so you have the consumer and the producer done. Now let's just print something out if I know how to type. There you go. So we're just going to print, let's say, gonna start listening. And now how to listen. So we're going to have an infinite while loop so that it keeps on running. And in the while loop, we're going to iterate through our consumer. So our consumer is the Kafka consumer. So every message in that consumer, for every message, we're going to print ongoing transaction just to simulate a transaction. And then here is going to be our message, which is going to be message.value. Because the message has multiple other metadata, but all we care about is the value, which is the actual payload. So we need to decode it, because remember we encoded it using UTF-8 over here. So we're going to decode it, and then we're going to turn the whole thing back into a dictionary. So all we need to do is just do a JSON.loads. And then pass that into it. That should be it. And then we're going to print the consumed message. There you go. So let's do this. Let's try this out. And then in our order backend, instead of sleeping for 10 seconds, let's just sleep for 5 seconds, just to make it easier. So transaction, all this is doing right now is in a while loop so that it indefinitely keeps on going. We are iterating through our consumer, and then every time there is a message in the consumer, we're decoding it, turning it into a dictionary, and then printing it out. So let's see. So we're gonna use the right hand side for the consumer and the left hand side for the producer. So transaction.py. So you can see it says gonna start listing and it doesn't have anything because there is no message right now. Let's do our order backend. This is gonna actually simulate and return the each of the results. Each of the order details. So yeah, after the first one, you can see we got the first one, wait 5 seconds. Get the second one, you can see order ID 2, everything is different. 3, so every time the producer is writing to Kafka, the consumer is reading from it. So that works for sure, right? So this should go all the way up to 15, but the idea is it should be pretty straightforward. We can give it like a few minutes to see it actually reach 15 so that it's much clearer. So I can give it a few minutes for it to like reach that. So we're gonna just wait. We're up to 9. So you can see we have 7, 8, 9, 10. Yeah, so this is working. We know that for sure. All right, so let's go back to the diagram. So we have orders backend done and the first part of transactions done, which is reading. And now what transactions also does is write back. So let's do that, right? Now that we know that the reading is working, once it reads the message, what it's gonna do is extract the user ID, which is gonna be the user ID, and then it's gonna get the total cost, which is gonna be the total cost. So these are essentially the user ID and the total cost from the producer. So we have the user ID and the total cost. Now let's form our data, which is gonna be, let's say, customer ID, which is gonna be the user ID. We're gonna have the customer email. Let's say this is gonna be the user ID at gmail.com. Right? So we have the email and then we'll have the total cost, which is gonna be the total cost. So this is gonna be the data we're gonna be sending downstream to Kafka. So let's just print successful transaction. And once everything is successful, we're gonna do a producer.send. Now that you're writing back to Kafka, you have to tell it which topic you're writing to. We're gonna be writing to order confirmed, which is the topic over here. And then we're gonna give it the data. Once again, we're gonna do data. We're gonna do json.dumps the data, and then we're gonna encode it using UTF-8. I think we're missing one parentheses. No, we have the correct number. All right, so this should be writing to the order confirmed Kafka topic now. So this part is done. We're reading and then we're writing. And now let's do the email backend. So the email backend is gonna be very simple. So I'm gonna keep some of the code. So we have our import JSON, and then similarly we have our consumer, the order confirmed topic, which is where our transactions is writing to. So we have order confirmed. We instantiate the consumer using that Kafka topic. And then we can go ahead and write this part again so that it makes more sense. So we have our email. So we're gonna keep track of how many emails were sent so far, so that you can see a unique email, so that you can see gradually the number go up. All right. So once again, we're gonna print something. let's just say email is listening, and then we're gonna have the infinite while loop, and then for message in consumer, we're gonna have the consumed message, which is gonna be message.value.decode, and then we're gonna put the whole thing in JSON.loads to get the dictionary, and then we're gonna get the customer email, which is gonna be our consumed message customer email. And then we have, let's just simulate the email being sent. So we can just do f string saying sending email to actually the customer email. And then to email sent so far, we're gonna just add our email so that we can keep track of how many unique emails it's going out to. And then we can just print out f string called so far email sent to, we're gonna take the length of our set. So far email sent to how many ever elements in the set, unique emails. All right, so that should be the email worker working. So now we have done this part too. So now let's see. So essentially what's going to happen is now the order backend is going to write a message to the order details topic once every 10 seconds. The transaction backend is going to read it in real time, write back to the Kafka with some more information such as the email. And then we have the email backend service, which is going to read from the order confirmed topic and we have a few print statements, and then we can keep track of how many emails going out. All right, so let's simulate that, right? So now we have our producer top left. We're gonna have our transactions top right. We're gonna have our email bottom left. So let's start with the email, right? So we're gonna do email. So email is listening. We have our order backend we have our transaction over here. That's gonna be our transaction. And then we're gonna have our order backend. So essentially order backend is gonna write to a topic. The transaction is gonna read. Transaction is gonna read and then write to a different topic that email is gonna read from, right? So we can see it happen in real time. First order, done, transaction processed it. User ID Tom1 and then Tom2. Email has been sent to 2 unique. We got 3. Here's the data for the third one. And we have 3. So you can see that it's processing it asynchronously, but very, very quickly. We're going to scale it up later on to show you how this works with a ton of data. But you get the idea, right? So 6, and then you'll see 7. So I'm just going to block 7, 7. Right, we're gonna get 8, 8, and 8. There you go. So we get 9. We have the order. We have the email. All right, and you can see that the unique emails is increasing because every email is the user ID at Gmail. So you can see we start from Tom1, 2, 3, 4, 5, all the way to 12. That's why each of them are unique that the emails are going out to. All right, we're gonna close it all. And now we have this working. Now the last part is going to be the analytics backend. So let's do that, and then we can see the whole thing working together. So for the analytics backend, we're going to have something similar. It's going to be another Python file over here called analytics.py. I'm going to delete this part, which has all the information. Here we're doing the same thing. We're instantiating a Kafka consumer. We have a topic called order confirmed, and then we're instantiating the consumer over here. So then we're gonna count the total orders. There you go. We will keep track of the revenue, which is gonna start from $0. We can say analytics, listening, we're gonna change our transaction to say transaction listening. That's gonna make things more clear. So we have analytics, listening, there you go. And then we're gonna have the while loop for every message in the consumer. Once again, we're just gonna have some text called updating analytics. And then we're gonna get the consumed message, which once again is gonna be the same. We get the message.value, decode, and then we're gonna put the whole thing in json.dumps. Sorry, I think it's gonna be loads. This is gonna be json.loads. And then in the from the consumed message, we're gonna get our total cost. This is gonna be a string in Kafka, so we wanna change it to a float. There you go. We have our total orders, order count. We're gonna increment it by 1. And then we have our total revenue. We're gonna increment it by the cost. And then we're gonna print out 2 f strings. One is gonna be orders so far today, and it's gonna have the orders count. And then we have another f string called revenue so far today, and this is gonna be the total revenue. All right, so now we have this done. So essentially what this is going to do is iterate through the order confirmed topic. Whenever there is a message, it's going to turn the message into a Python dictionary, extract the total cost from that message, increment the local count by 1 because it's another new order that came in, increment the revenue by the total cost in that order, and then print out the updated revenue and order count. All right, so looking back over here, so we have our orders backend writing some fake orders to Kafka under the order details Kafka topic. Transactions backend is reading from it and then writing back to the Kafka to a different topic called order confirmed. Our email backend is reading from that order confirmed topic. And our analytics backend is also reading from that order confirmed topic and printing out some stats. And if we look at the order backend, we're gonna have one order being generated every 10 seconds. All right, so we're gonna actually have every 5 seconds. Okay. Alrighty, so let's clear these up. All right, top left, we're gonna have our transactions pie. Bottom left, we're gonna have our email. And then bottom right, we're gonna have our analytics. There you go. Now let's start generating our orders, which is gonna be order backend. All right, so you see after the first one, we already have analytics count 1, revenue 2. We have 2 and 6, 3 and 12, so we keep on adding to it. And this is going on very quickly in real time. Right? So we'll let this run while we go back over here. So now you can see every time a client orders a food in real time, we're doing the transactions, confirming the orders. Once the order is confirmed, we're emailing and also doing some analytics. Everything is being done using Kafka or data pipeline. So everything is decoupled and not strongly related to each other. So now that we have a base version working, I'm gonna scale this up to a lot of orders and see how that works. All right, we're gonna clear everything up. All right, so we cleared everything up. Now what we're gonna do is, let's not wait. We're gonna stop sleeping after every order. we're gonna hike up the order limit to, let's say, 20,000. All right, so there's gonna be 20,000 orders that we're gonna do one after another without sleeping at all. So what we would expect is the order is just going very, very quickly, and we should see the other services / Python files process every order immediately. So once again, we're gonna have our transactions running here. We're gonna have our email running here. We're gonna have our analytics running here. Now let's do this. All right, you can see the order backend generating orders very quickly, and all of them are processing it almost immediately. So we're up to 14,000 orders, and you can see these are processing them one by one. We're done generating all the orders, and given the whole system is decoupled, all of our other workers are still processing everything. So we're gonna wait. So we're in 12,000. You can see we have 15,000 unique emails. This is going. It's gonna keep on going. Yeah. So the whole system is decoupled. We can scale them up individually. So a cool thing you can do right now is, given all of these are decoupled, let's say, in our case, we have individual Python files to make things simple. But in a production setting, these are going to be like individual services or other kind of like isolated processes running. So you can essentially scale them up and down independently. You don't have to worry about scaling the whole thing up. If your analytic system is much more time consuming and compute intensive, you can scale that up while the others are working in a lower version. All right, so let's do, so if you look at this over here, you can see orders so far today, we go up to 19,988, and revenue so far is also very, very high. Right. One thing to note is you can see that the order so far is 19,988. So we have around 12 missing because we did 20,000. The reason that happened is when setting up Kafka, you can tell Kafka how much message loss you're okay with. If you want your system to work very quickly, you can tell Kafka I'm okay missing out or losing a few messages. And that's why, given we were writing very, very quickly, it lost around 12 messages. If you don't want to lose any message, you can configure Kafka to do that. That works too. But in our case, I just used the basic Kafka version, which is configured like that. All right, and the last thing we're gonna do is do an even higher number. So let's kick them off. Let's do order backend. Sorry, this is going to be a transaction. We're going to have email, and we're going to have analytics. And for the backend, let's bump this up to 100,000. I wonder if we can do 1,000,000. Let's do 1,000,000. So 100. Let's do 1,000,000 orders. Alright, we're gonna try doing 1,000,000 orders and see what happens, alright? Pretty sure things are gonna break, but why not give it a go? Orders back in. Alright, so this is gonna keep crunching, and we're gonna wait to see till how much does it go, and then quit it. So this is going, we're up to 20,000. Alright. Yep, so we are past 20,000, which was our limit last time. So let's just wait till it goes to maybe 100,000, and it's gonna be a good. So you see how quickly it's happening? It's gonna be in real time, and you can scale all your other services independently. And the cool thing is Kafka also works as a database. So the messages you're writing to Kafka, they are gonna be retained in Kafka. So you can configure Kafka to tell it how long to hold on to messages. So for a given topic, you can tell Kafka to indefinitely hold your messages. That means what happens is, if for some reason your downstream or upstream services that read from Kafka are down, you don't have to worry about losing data, because Kafka is going to retain that data And whenever your upstream or downstream services are back up and running, they can restart reading from Kafka wherever they stopped. Makes sense? So it's a very cool middleware to have, so that you have this one kind of like a pipe where all your data is, and then you have different things hooking up to it and reading as needed. Yep, so you can see we're up to like 160,000, so, and everything is still running, so things are going pretty smoothly, and you can scale things up and down independently, which makes the whole system very, very scalable. I'm gonna stop producing. So we produced up to 184,000. Let me see if they catch up to like the 184,000. We're gonna go over here. So so we have the whole thing built. We have our orders backend, which is simulating the orders and writing to Kafka. We have our transactions backend, which is reading from Kafka and writing back to Kafka to a different topic. And we have the email backend and analytics backend, both of which are listening from order confirmed topic and then printing out some text to our console using its local state, so that we can see how these processes can be stateful. They don't have to be stateless. So as you're processing, as you're consuming and processing from Kafka, you can either use a database or a cache to retain data and do any computation that you may need to. And yeah, so this is 92,000, so I'm gonna shut them down because it's gonna take them forever to do it. Once again, this whole thing is running locally, so you can understand why this is gonna take a long time. In a production setting, you're gonna have way more instances scaling up and scaling down, so things are gonna be much, much quicker. With that being said, I think that's pretty much all I had for you today. So hopefully this was a good demo of how you can use Python and Kafka together. Once again, the whole thing is just for demo purposes. If you want to actually build a production grade app, you will have to deploy things using AWS or DigitalOcean instead of running things locally. But hopefully you learned a ton. Let me know if you have any questions, and I will catch you guys in the next one. Bye-bye.